Good afternoon, students. So now I am going to start the last approximate method of structural analysis from unit 6, that is the cantilever method. So this is again the method used for the analysis of the lateral loads. So just first we'll see the introduction of this method, and based on this we'll cover one problem. So again this method is used for the high story structure, that is tall building, and it is used satisfactorily for buildings of 25 to 35 stories tall. Compared to the portal method, so this method gives good results for high narrow buildings compared to those from the portal method, but it is not popular as the portal method. We'll see the simplifying assumptions made in the cantilever method. The first assumption is that, again, the two assumptions are same like in a portal method. The point of contraflexure occurs at the center of each beam. Point of contraflexure occurs at the center of each column. And this third assumption is important, that is the direct stresses in the columns are proportional to their distances from the centroidal vertical axis of the frame. So with the help of this third assumptions, we're going to find out the forces in the column, and for that to find out the forces in the columns, the stress of the columns, it is proportional to the distances from the centroidal vertical axis of the frame. So whatever the given frame is there. So first of all, you have to locate the centroidal vertical axis of the given frame. And then according to the assumption number 3, you have to find out the axial forces in the columns. So again here in this method, the steps which is involved here, that is the same steps you have to follow like a portal method, but it is opposite to that. Means in portal method we got the axial forces in the columns last step. Here you get the axial forces in the column in the first step itself. Then column axial force, then column moment, beam shear, beam moment, like that. So exactly opposite to the portal method, but same calculations you have to do using this method. Now this is important para. This method assumes the building frame as a vertical cantilever fixed at base and free at top and subjected to lateral loads. So generally this method is used to for the analysis of wind loads. So why this is called as a cantilever method, and why it is a cantilever frame? Because it consists of a building frame which is a vertical cantilever fixed at base and free at top, and it will be subjected to the wind loads. Hence the columns on the windward side will be in tension and on the leeward side will be in compression. So this is one of the, we can say in the assumptions that as this is a cantilever frame, the columns on the windward side, you know this windward and the leeward side of the frame. So the column which is on the windward side will be in tension and the leeward side will be in the compression. Okay. Accordingly, we have to show the force in the column member. So the column which is on the windward side, the force will be developed, that is a tensile force, and the column which is on the leeward side will be on the compression. Okay. According to this sentence, we'll have to analyze the frame. Assuming the wind to blow from left to right, the wind load will cause a clockwise overturning movement. Okay, we will assume that the wind will blows from the left to right. The wind load will cause a clockwise overturning movement. So for an equilibrium, an equal and opposite movement will have to be developed by the frame. This will be made available by the axial forces in the columns, which will be tensile in the windward columns. So आपको इतना ही ध्यान में रखना है कि जो कॉलम्स विंडवर्ड साइड में है वहां पे टेंसाइल फोर्स रहेगा, एंड जो लीवर्ड कॉलम्स है वहां पे कंप्रेसिव फोर्स है, एंड विल बी सच मैग्नीट्यूड as to create an anti-clockwise movement required for the equilibrium. Okay, so equilibrium of the frame should be satisfied whatever the load acting on the frame, lateral load. Okay, so that will cause the clockwise overturning movement. Okay, if you assume the wind to blow from left to right, the wind load will cause a clockwise overturning movement. So that we will see while considering the problem. So for equilibrium, an equal and opposite moment will have to be developed by the frame. So ये कैसे possible होगा? That is with the help of the axial forces in the columns. Okay, so that we will see while taking a problem. So this is the introduction of the cantilever method. Okay, and these two paras are very important. Okay, why this axial force in the column is tension and the compressive force. And again, these three assumptions you have to keep in mind. Okay, first two assumptions are same as Portal method, and third assumption is direct stress in the column. So stress is force per unit area. Okay, so force means axial force in the column that is proportional to the distances from the centroidal vertical axis of the frame. So for that you need to require to locate the centroidal vertical axis of the frame. Okay, so directly I will start the problem and I will explain you how to solve that problem using the cantilever method. So this is a problem here. Analyze the frame shown in figure by cantilever method and plot SFD and BMD. The area of column member is shown in the given figure. So here in this frame, the area is given. Okay, you can see the area of the given figure. This is again 3 by 2 story frame. Okay, and this load we have considered as a wind load, lateral load. Okay, though again the area is mentioned here. You can see for this corner member exterior column the area is A for upper and lower story frame, and for this intermediate column it is 2A, and for this column it is 1.5A. Okay, so this is the area is given here. Okay, but suppose the area is not mentioned in the problem, you have to assume the same area for all the upper and lower story column member. Okay, please keep this note. If it is not given in the problem, you assume the area for all members are same. Okay, so this is a given frame and we have to analyze it by the cantilever method. So these are the steps you have to follow. What analysis results you have to find out. Again the same analysis result you have to find out as we find out in the portal method, but this is opposite to that, exactly vice versa है. ठीक है, तो सबसे पहले as per the assumption number 3 क्या दिया है, direct stresses in the columns that is proportional to the distance of the centroidal axis of the frame, है ना. इसीलिए आपको to find out the axial forces in the column सबसे पहले अपन फाइंड आउट करेंगे है axial force in column. So to get the axial force in the columns for upper and lower story, first of all we will locate the CG of the frame. किसका CG locate करना है, frame का CG locate करना है, और the location of the centroidal vertical axis VY YY axis अपने को locate करना है, यानी उसका X जो है that CG that we have to find out. Okay, मतलब जो 100 किलो न्यूटन लोड का जो मोमेंट आएगा about this axis, that will, if you assume the wind blows from left to right, it will create a clockwise overturning moment. It will create a clockwise overturning moment about this axis. तो इस तरह से these are the column member. Hence the column which is windward side, okay, that column will produce the tensile force, and the column which is on the leeward side that will produce the compressive force. Okay, because due to this force it will create a clockwise overturning moment. So you have to take the direction of force in the column member in a such a way that it will create a anti-clockwise moment to maintain the equilibrium of the frame. Then after location of the CG, you'll have to find out the axial force in the columns. Then third step, from axial force you have to find out the beam shear. From beam shear you have to find out the beam moment, and from beam moment you have to find out the column moment. Again all the calculations you have to calculate it on the frame. Okay, so we will see one by one. So here I have written here the note, if area is not given then assume same area for all 4 floors. Okay, now this is a given frame and this is a distance, a vertical distance is given 3 meter 4 meter, and horizontal is also given. So first step we'll find out we'll locate the centroidal vertical axis of the frame. We'll locate the CG of this frame. तो उसके लिए अपन reference point जो choose करेंगे, we will always we are considering the reference point as a corner point. Corner point choose करते हैं, तो अपन ये frame के लिए अपने को क्या करना है, तो we will consider this reference point, this AER. ओके, ये कॉलम को कंसिडर करेंगे एज अ रेफरेंस मेंबर, एज अ रेफरेंस कॉलम। ओके, कोई एक रेफरेंस अपने को लेना है तो जनरली कॉर्नर से अपन उसको लोकेट करेंगे। So we'll consider this column as a reference point, that is column AEI. Okay. Now here in the solution you can see to locate the centroidal axis that I have considered it. It is YY. Okay. Let us take the moment of areas. You know that the x bar we are calculating with the help of, that is a1 into x1 plus a2 into x2 plus a3 into x3 divided by whole area. So we'll take the moment of areas of the columns about point A. So taking moment of areas of the columns about we have considered this column for upper story, these two members we have considered as a this reference. Okay, this as a reference we have considered. Okay, so you can see here again I have plotted this frame. Okay, so this we have considered as reference and this area is given. तो ये रेफरेंस अपने को लेना है. सो व्हाट इज योर एक्स बार समेशन ऑफ ए इंटू एक्स. ठीक है, तो पहले इसमें कंसिडर x1, x2, x3 एंड x4. ओके, तो पहले अपने को ये सेंट्रोइडल एक्सिस लोकेट करना है, एक्स बार फाइंड आउट करना है, एक्स बार फाइंड आउट करना है. तो एक्स बार फाइंड आउट करने के लिए यू जस्ट use this relation summation area into x. We'll take the moment of areas. Okay, for locating of this centroidal axis, take the moment of areas of the columns about AEI. So this is directly upper story lower story का calculation साथ में करेंगे. So 2 why 2 into a upper lower story area. Okay, so ये हो गया twice a, लेकिन ये रेफरेंस ले रहे तो इसका परपेंडिकुलर डिस्टेंस कितना हो गया और उसका सेंट्रोइड कितना होगा, ये रेफरेंस ले रहे तो इंटू 0 हो जाएगा. ओके, इंटू 0. देन विल टेक दिस कॉलम मोमेंट ऑफ एरियाज ऑफ दिस कॉलम. सो मींस एरिया इनटू द परपेंडिकुलर डिस्टेंस, सो अपर एंड लोअर स्टोरी. सो इसीलिए 2 इंटू ट्वाइस ए दोनों फ्लोर के लिए. ओके, दोनों मेंबर के लिए. सो 2 into twice a into perpendicular distance. What is the perpendicular distance? This is our reference line. This is our reference column. इसके रेफरेंस के लिए थ्रू लेना है. तो पहला कॉलम जो अपन ने लिया 2 into a plus a twice a है, इसलिए twice a. ये कॉलम का रेफरेंस ले रहे हैं इसलिए पहले इसमें 0 है परपेंडिकुलर डिस्टेंस. प्लस सेकेंड कॉलम, ये सेकेंड है, इसमें twice a plus twice a 4a. So 2 into twice a into the perpendicular distance यहाँ तक 4. Okay, plus ये 1.5 a 1.5, that is 2 into 1.5 a into the perpendicular distance. What is the perpendicular distance? 5 plus 4. 5 plus 4. यहाँ से इस कॉलम से परपेंडिकुलर डिस्टेंस that is 9 meter. So 2 into 1.5 a into 9 प्लस यहाँ पे a plus a. ओके, लास्ट कॉलम a plus a, so it is twice a. So twice a into what is the perpendicular distance? It is 15 meter. It is 15 meter. So 6 plus 5 11 plus 4, that is 15. Okay, so twice a into 15 divided by whole area of the frame. So whole area of the frame, this frame, both the column members, the area is twice a plus 2 into twice a, that is 4a plus 2 into 1.5 a plus 2a. Okay, if you solve this, you will get the centroid of this frame, and that centroid, it is located 6.64 meter from this reference line of this column member. यहाँ से centroid locate किया है at a distance of 6.64 meter. So we'll get this centroidal vertical axis of the frame, and where we have located the centroid of this frame. Okay, so first step is the location of the vertical axis or the location of the centroidal axis. Okay, it is located at a distance of 6.64 meter. Now once you'll get this value x bar, you can find out the distance of each column member from the centroidal axis. From the centroidal axis. So like this column member, first column, upper and lower story, what is the distance of this column member from the centroidal vertical axis? It will be same as x bar. It will be same as x bar. So यहाँ से यहाँ तक का distance जो रहेगा, that is x bar, which is equal to x1. Okay. So after locating x bar value, locate the values of x1, x2, x3 and x4 of each member from the centroidal vertical axis. So x bar equal to x bar, that will be equal to 6.64. Then similarly you second member of the frame, second column member of the frame, and locate the distance of this second member from the centroidal axis. So that we have considered as x2. So what is that distance? Total is this is 6.64. You just minus this, you'll get that value. Okay, so here I have shown that calculation. Okay, likewise you have to find out the value of x1, x2, value of x3, and what is and the value of x4, the value of x4. So these distances are given. You can find out the value of x1. So x1 you can see here. You see this, I have shown the calculation here. x1 is nothing but x bar. x1 is nothing but x bar, which is equal to 6.64. Then you have to find out the value of x2. x2 will be equal to 6.64 minus 4. That is 2.64. Then x3 means this distance. So x3 again you can find out the total is 9 meter. So this member is located. This member is located. Third member is located at a distance of 9 meter from this reference. So this is 6.64. So 9 minus 6.64, you'll get 2.36. Then similarly find out x4. So x4 and this fourth member of this column is located at a distance of 15 meter. So 15 minus 6.64, you'll get this distance as x4. You'll get this distance as x4. Why you need this distance of each member from the centroidal vertical axis? Because we have to calculate the actual forces in the columns as per the assumption number 3. Okay. So what is your assumption 3? Your assumption is 3 in the cantilever method. It is the stress is directly proportional the distances from the centroidal vertical axis of the frame. पूरे कॉलम मेंबर का जो डिस्टेंस है फ्रॉम द सेंट्रोइडल वर्टिकल एक्सिस उससे वो डायरेक्टली प्रोपोर्शनल रहेगा द स्ट्रेस व्हिच इज डेवलप्ड इन द कॉलम मेंबर. So in this way we find out the values of x1, x2, x3 and x4 after finding out the value of x bar. Okay, and here this figure you can see this is a stress diagram of the column which shows the forces in the columns. Okay, that is V1, V2, V3, V4. These are the actual forces in the column. So here this is the CG of the frame, and as these are the columns we will consider as the windward side column. We'll consider the force in this column will be developed as a tensile force, and as this column will consider as a leeward side column, we'll consider the force developed in this column as a compressive force. So accordingly, you get the stress diagram of this column, stress diagram in this column. Okay, so after finding out this vertical centroidal axis distance and after locating this, we'll go with the second step. So in the second step, we have to calculate the axial forces in the columns. So how will get these axial forces in the columns? Axial forces in the columns you'll get with the help of this third assumption. That is, stress is directly proportional to the distances from the centroidal vertical axis. Okay. So we'll use this relation. So stress, you know that sigma. Sigma, it is the ratio of force per unit area. Ratio of force per unit area. And the stress is directly proportional to the distance. That means sigma is directly proportional to x. Okay, x is distance of each member from the centroidal vertical axis. So sigma is nothing but P by A. Force per unit, and that P is nothing but force. Okay, so that force in each column of upper and lower story we have denoted it by V, V1, V2, V3 and V4. So according to that assumptions, we'll find out the relation in terms of distances, and then we'll be able to find out the values of V1, V2, V3 and V4. So first of all, we'll make a relation of that. So for this first case, first column of this stories, that is sigma is directly proportional to x, that is x1. So sigma I have replaced it with by V1 by area, force by area. And how much force I have considered? That is V1. Okay, V1 I have considered. So V1 by A is directly proportional to x1. So if you solve this, V1 by A equal to K into x1. V1 by A is equal to K into x1. This is the constant of proportionality. So K you can write down V1 by A divided by x1. x1 value अपने को पता है, area पता है, तो we can find out the value of V1. Okay. Similarly, we will go with the second, third and fourth relation. We'll get the four relations. Okay. So similarly, we can write down the relation that is for second column member V2 by twice A. But here you have to take a note that you just see the area of the frame. जैसे first इसमें first column upper and lower story, it is area A. Okay, and here it is twice A. V2 by twice A. So V2 by twice A is directly proportional to x2. So V2 by twice A, which is equal to K into x2. Okay. So again, we'll get the value of K, that is V2 by twice A divided by x2. Similarly, we can find out the relation, or we can write down it is for all the columns. So for third and fourth column, the area is 1.5 A, and fourth column it is area A. So we can write down, we have this relation. So from all the four equations, we'll get this relation K equal to. Okay, K equal to. So from 1, 2, 3 and 4, I have written only two equations here. Directly I have written here. So directly you'll get the K value from the first equation. It is V1 by A divided by x1. V1 by A divided by x1. Okay. So you just write down this for all columns, V1 by A divided by x1, which is equal to V2 by twice A divided by x2. Similarly, it is equal to V3, what for third column, it is 1.5A. So V3 by 1.5A divided by x3 equal to V4 by area is A divided by x4. Now, I told you how to find out this x1, x2, x3, x4. x1, x2 निकाल दिया. Then we'll put the value of x1, x2, x3 and x4 here. So this relation you will get. You get this relation. Okay. So from this relation, or from equating any of the two equations, we get the value of axial forces in the column member. Okay, but for that you need a relation of some force in terms of the other. Okay, like you should know the relation of V1 in terms of V2 or V2 in terms of V1. Okay, so we are having this relation, and with the use of this relation we will find out the axial force in the column members. Okay, so I think you got those two steps. Again, axial force we have not calculated it. We'll calculate in the next steps. Okay, only we have this relation between the force and the distances. Okay, stress by area. Okay, then I'll go to the next slide. So first of all, to get that relation, we cannot consider it directly the both the frames simultaneously. Only we find out the relations. The same relation will be applicable to the both the frames. That relations we have found out. Now, to get the axial forces in the columns. Okay, because axial force will be different, because for upper story it is different and lower story it is different because of this loading. Okay, so to get that axial force, we will consider first the lower story column. Okay, we consider the lower story column. So here you have to show the frame just above the point of contraflexure of columns. So as per the assumption 1 and 2, you can see here. Here the point of contraflexure. सबसे पहले आपको you have to locate the point of contraflexure at the center of each beam and center of each column. Okay, so you can see here the point of contraflexure is located at the center of beam and the center of the column. So here you can see that this is a lower story frame and this is the point of contraflexure. Okay, so to get the axial forces in the lower story column, okay, we'll have to show the frame just above the point of contraflexure of columns. That is, first of all, we have to consider the lower story column. We have to consider the lower story column. So here you can see that upper story आपको as it is draw करना है. Lower story में you have to show the frame just above the point of contraflexure. I have shown the frame just above the, मतलब यहाँ से इसको break कर दिया अपन ने. Okay, so this is the frame I have shown. Okay, I have shown all the loading as it is here. Then I have shown the distances x1, x2, x3, x4, and here I have considered these two columns as a windward side column. So as this is a windward side column, the force is developed here is a tensile force, and this is a leeward side column. Okay, this is the CG of the frame. We'll consider this is the leeward side column. So the force which is developed in this column will be the compressive force. Okay, so accordingly we can plot the stress diagram for the columns. That is V1, V2. This will be upward V3 and this will be upward V4. Okay, now after considering this frame just above the point of contraflexure, we get these axial forces, that is V1, V2, V3 and V4. Then that we will find out. So from equation A, here you can see that this is a equation A. Any two equation we will equate, any two equations. Okay, out of this four we'll equate any two equations. Okay, so that we will consider as equation A. Okay, we are having this equation. Okay, and out of this equation I will equate this equation. Okay, V1 and V2 का equation अपन equate करेंगे. So you can see here V1 by A divided by 6.64 is equal to V2 by twice A divided by 2.64. Okay, so after simplifying this, V1 divided by 6.64A is equal to V2 2.64 into 2A. तो ये इक्वेटिंग ऑफ दिस टू इक्वेशन विल गेट द रिलेशन ऑफ V2 in terms of V1. In terms of V1. Likewise, you can find out the relation of V1 in terms of V3, in terms of V4. Okay, means all the values of V2, V3 and V4 you find out the relation in terms of V1. किसी एक वैल्यू को अपने को एक एज अ अपने को फैक्टर एक कंसिडर कांस्टेंट कंसिडर करना है. तो जैसे अपन ने V1 को एक कंसिडर किया है एंड इन टर्म्स ऑफ दैट V1 we will find out the relation of V2, V3 and V4. So first of all, to get the relation of V2 in terms of V1, we will equate this equation. We will equate this equation. So V1 by A divide. We'll simplify this. We'll get this relation. Okay. So which relation you got? If you are having the calculators with you, you just go through this. And you'll get this relation 5.28 V1 is equal to 6.64 V2. 5.28 V1 is equal to 6.64 V2. Now find out the value of V2 in terms of V1. In terms of V1. तो ये relation आपको मिल रहा है. Okay, this is your first relation. Then again you go with this relation, that is V1 by A divided by 6.64 is equal to this relation. Okay, you are having this relation. You are having this relation with you. So V1 by A, equate this relation to third relation. Then equate first to fourth relation. Okay, so you'll get the value of V3 in terms of V1. So here I have shown it, shown this calculation. So if you simplify this, you get the value of V3 in terms of V1. The value of, for that we use this relation V1 by A divided by 6.64 is equal to V3 by 1.58 divided by 2.36. ये आपको second equation मिला. Now V4 1.26 V1. V4 के लिए again you have to use this relation V1 by A divided by 6.64 is equal to जो V4 का relation है. Okay, that is V4 wait a minute. please be there. यस, स्क्रीन दिख रही है अभी? From both the sections. So here we are finished up to this. I think यहाँ तक कि आपको समझ में आया होगा. If you are having any doubt, you can ask me. Otherwise, I will continue to the next step. Okay? So ये relations अपने को मिले हैं पूरे V1, V2, V3 and V4. So with the help of this, if you know the value of V1, if you get the value of V1, you will able to find out the values of V2, V3 and V4. ठीक है? First of all, we have find out the relations of that. Now we'll use the moment condition and we will find out the value of V1 by taking the moment. So these points I have given, point number 1, point 2, point 3 and point 4. You can see this points here. पहले कॉलम जो मेंबर है that is given point 1, 2, 3 and 4. And to get the value of the force V1, okay, क्योंकि relations अपन ने पूरा in terms of V1 find out किया है, तो कोई भी एक इसका भी वैल्यू अगर आपने निकाला, अपने को V1 की वैल्यू निकालनी है, तो we will take the moment at any point. You can take the moment at any point. Okay, out of these 4 points, you can take the moment at any point. Moment of what? Moment of this lateral load, okay, and moment of this axial forces, and moment of this axial forces. ठीक है? Because we are considering the whole frame for the equilibrium, and we will take the moment of that moment of all the forces acting on this frame about any point. So इसमें मोमेंट किस किस का आएगा? एक्शियल फोर्स का और लैटरल लोड का. ओके, सो एज वी हैव कंसीडर्ड द लोअर स्टोरी कॉलम, बोथ जो लैटरल लोड है उसी का मोमेंट आएगा. सो हियर I have considered point number 4. I have considered point number 4. I can take point 2, 3 also. Okay, 1 I cannot take because V1 I have to find out. Okay, so I will take the moment at 4. So first of all we consider this 100 kilonewton load, this 100 kilonewton load, and we'll take the moment of this 100 kilonewton load. Okay, moment of this 100 kilo about point number 4. About point number 4. This is your point number 4, and we'll take the moment of this. So force into the perpendicular distance. Okay, what is the perpendicular distance? यहाँ पे आप देखो, जैसे please don't be confused. जो lower story अपन ने consider किया है, that is the frame just above the point of contact flexure. So this is the point of contact flexure is located exactly at the center of this column. Okay, so if you see in the problem figure, ये पूरा distance as it is 3 meter है, but ये जो distance है that is 4 meter. that is 4 meter. Okay, and as we have considered this point of contraflexure, you can see here this is 4 meter, सेंटर में लिया है तो वो डिस्टेंस रहेगा अप टू द पॉइंट ऑफ कॉन्ट्राफ्लेक्चर इट इज 2 मीटर. ओके, सो एग्जैक्टली ये हाइट ऑफ दिस लोअर स्टोरी कॉलम विल बी इक्वल टू h/2 हो जाएगा. तो ये जो डिस्टेंस है दैट इज 2 मीटर. ओके, because accordingly we have shown the frame like this. So moment of this 100 kilonewton towards this point number 4. So 100 into 4, 100 into 5, 3 plus 2 5, plus again it will rotate in the clockwise direction, 100 into 2. Okay, 100 into perpendicular distance, that is 100 into 2. Then V1, this is a force we have shown is a tensile force, so it is in the downward direction. So V1 into the perpendicular distance, so minus V1 into the perpendicular distance कितना है, total distance जो है that is 15. Okay, 4 plus 6 plus 5, so it is 15. Then minus V2 into the perpendicular distance, that is 2.64 plus 8.36. You can see that problem will get that distance, plus V3 into 6. अभी प्लस ये क्लॉकवाइज जा रहा है, ये दोनों एंटी क्लॉकवाइज है, सो इट इज माइनस V1 माइनस V2. ओके, एंड V3 is clockwise, V3 into the perpendicular, that is 6. Okay, so you'll get this moment equation. We take the moment about 0.4. Okay, so after solving this you'll get the value of V1 which is equal to 34.04 kilonewton. Okay, after solving this you'll get the value of V1 is 34. यहाँ पे V2 in terms of V1 put करो, V3 in terms of V1 put करो. ठीक है, V2 0.795 V1, V3 0.53 V1. ये आप after putting this relation in terms of V1 you solve this, you'll get V1 is 34.04 kilonewton. So this is we got the axial force in the lower columns, in the lower story columns. कितना मिला, 34.04 for the lower story column. Then find out V2, V3 and V4 using this relation. Put the value of V1, you get, so V2 is 27.06, V3 is 18.04 and V4 is 42.89. Okay, so these are the axial forces in column 1, 2, 3 and 4 of lower story. Okay, similarly we'll consider for upper story column. For upper story column, so for upper story column again we have to find out the axial forces, so that I have denoted it by V1 dash, V2 dash, V3 dash and V4 dash. Okay, so here again we'll show the frame just above the point of contraflexure of the upper story. So this is how I will consider upper story and the frame just above the point of contraflexure. So the total जो distance है of this frame, okay, this frame distance upper story, this distance is 3 meter, and I have shown the section or the frame just above this point because the point of contraflexure is located at the center of the column. So only this portion I have shown here. Okay, the frame just above the point of contraflexure, and here we will get we will show the axial forces in the column. These two force in the column will be downward and this will be in the upward direction. So again you have to find out the upper story column force. Okay, तो इसीलिए अपन ने upper story column यूज किया. तो ये जो distance है टोटल 3 मीटर है अपर स्टोरी कॉलम की हाइट, बट ये अबोव द पॉइंट ऑफ कॉन्ट्राफ्लेक्चर है, सो दिस विल बिकम 1.5 मीटर. ओके, दिस विल बिकम 1.5 रिटन हियर. ओके, एंड दिस ओनली अपर स्टोरी में सिर्फ 100 किलो न्यूटन लोड रहेगा. जब अपन लोअर स्टोरी कॉलम कंसीडर करेंगे तो बोथ द लोड विल बी देयर. देन अगेन you have to take the moment about 0.4. Relation same रहेगा, V1 by A is equal to V2 by A divided by that. Why relation will be same? Because area same है, distance same है, सिर्फ relation में आपको V1 को रिप्लेस करना है V1 डैश से, सेम रिलेशन रहेगा. ओके, दैट इज सिर्फ V1 you have to write down V1 dash and V2 you have to write down V2 dash. The same relations रहेगा. Just we have find out for the lower story column. Same relation will be there. Only the value of V1 dash will be changed. Means all the values will change, but relation आपको वही यूज करना है. तो अगेन फिर से आपको you have to take the moment of all forces about 0.4. Okay, you have to take the moment of all force about 0.4 or moment of this frame. Okay, so 100 into perpendicular distance. So 100 into 1.5. 100 into 1.5 minus ये एंटी क्लॉकवाइज जाएगा, ये एंटी क्लॉकवाइज into this point. So minus V1 dash into 50 minus ये भी एंटी क्लॉकवाइज जाएगा V2 dash into the perpendicular distance, that is 2.64 plus 8.3. डायरेक्टली आपको ये डिस्टेंस पता है in the problem figure, plus V3 dash into 6. V3 dash into 6 is equal to 0. We'll get the value of V1 dash. Put the value of V2 dash, this relation, V3 dash, this relation. Okay, so you'll get the value of V1 dash, V2 dash, V3 dash and V4 dash. So ये जो values है, these are the axial forces in the upper story column. और इसके पहले जो values निकली V1, V2, V3, V4, these are the values of lower story column. So आपको यहाँ तक पूरा follow करना है to get the actual forces in the columns. ठीक है, पहले तो सेंट्रोइड एक्सिस लोकेट करो, उसके बाद assumption number 3 से find out the relations, then consider the lower story column and find out the axial forces, then consider the upper story column and find out the axial forces of upper story column. ठीक है, तो these are the axial forces you will get. Then after getting the axial forces in the column, your next step is calculation of beam shear. Calculation of beam shear. So ये calculation अपन कैसे करते हैं? From the column shear or column axial force, we will be find out the beam shear. Exactly opposite to the portal method. तो यहाँ पे फिर से आपको पूरा calculation frame में ही करना है. तो here only I have shown the column member and the beam member. दो इसको split up कर दिया, दो story को members को यहाँ से divide कर दिया column and beam member को. So there are 4 column members and 4 column members for upper and lower story column and 3 beam members for the upper and the lower story column. So after splitting of this members of beam and column, जो आपको lower story column में axial forces मिले हैं, जैसे ये पहले lower story column में मिला, lower story column में, तो this is a lower story column. So what is the value of this V1 you got? V1 is 34.0. All values are positive values. Okay, all values are positive. Positive means we are considering this as a force is developed is the tensile nature. Negative means we are saying the force is developed, it is the compressive force. Okay, yeah, you have to show it like this. You can see here, this is the first is 34.04. Then here you can see it is not like that. Please concentrate here. जैसे ये लोअर स्टोरी कॉलम है, ये मेंबर है, पहला मेंबर. तो ये दो इसमें जो है, इसमें टेंसाइल फोर्स है, जो अपन ने शो एजम्पशन किया विंडवर्ड साइड कॉलम, वी हैव कंसीडर्ड दिस एज अ टेंसाइल फोर्स. तो ये डाउनवर्ड है, तो जैसे कंसीडर किया वैसे ही दिखाना पड़ेगा. ओके, इट इज नॉट बेस्ड ऑन पॉजिटिव नेगेटिव. ओके, तो यहाँ पे ये दो डाउनवर्ड है और ये दो अपवर्ड है. दिस वी हैव कंसीडर्ड एज कॉम्प्रेसिव। सेम अपन ने इसमें भी एज्यूम किया अपर स्टोरी, ये दो डाउनवर्ड, ओके, एंड दिस इज अपवर्ड, दिस इज अपवर्ड, ओके। सो दिस डाउनवर्ड मैग्नीट्यूड, ये डाउनवर्ड है तो ये अपवर्ड रहेगा, दिस इज डाउनवर्ड, दिस इज अपवर्ड, this is upward, this is compressive, so this is downward, okay, and this is upward, so this is downward. So जितनी values है आपकी, this is the value of V1, this is value of V2, this is value of V3, and this is the value of V4. V1 V2 downward and V3 V4 upward. Then as this is downward, this will be in the upward, okay. Likewise you have to show the axial forces in the lower story column. Similarly we'll show the for upper story column. तो यहाँ पे this is again downward, so this is V1 dash, it is 7.3 downward, V2 dash 5.81 downward, this is V3 dash, this is upward 3.81, and V4 dash, this is upward. जैसे अपन ने यहाँ पे नेचर शो किया है, जैसे ऐसे वैसे ही आपको यहाँ पे बताना है, ओके। दो साइड के कॉलम में डाउनवर्ड है और लीवर्ड साइड कॉलम में अपवर्ड है, ठीक है। तो as this is downward, this will be upward, okay. So in this way you have to show the axial forces for upper story and the lower story column. Then from this column you have to find out the values of beam shear. तो जैसे ये अपवर्ड है, डाउनवर्ड, ये अपवर्ड, ये डाउनवर्ड है, एक्शन देयर इज इक्वल एंड अपोजिट डायरेक्शन, दिस इज अपवर्ड, दिस इज डाउनवर्ड, ये डाउनवर्ड, ये अपवर्ड रहेगा, क्योंकि यहाँ पे पॉइंट ऑफ कॉन्ट्रैक्ट फ्लेक्चर लोकेटेड है, ओके। सो दिस विल बी डाउनवर्ड, दिस विल बी अपवर्ड, बिकॉज V1 plus V2 is equal to 0, so V1 is equal to minus V2. तो ये डाउनवर्ड, ये अपवर्ड, अभी ये अपवर्ड मिल गया, ये भी अपवर्ड मिला आपको यहाँ से, तो इसकी एडिशन करो, 7.3 plus 5.81, ये अपवर्ड है 13.81, तो यहाँ पे आएगा डाउनवर्ड, दिस इज डाउनवर्ड, दिस विल बी अपवर्ड, ओके। सो दिस इज 13.1 एंड दिस इज डाउनवर्ड 3.86, सो plus 13.1 minus 3.86, you will get plus 9.19, तो यहाँ पे डाउनवर्ड। लाइकवाइज यू हैव टू गो डू द कैलकुलेशन, तो आई थिंक आपको ये पूरा आ जाएगा। अभी सॉरी, जैसे यहाँ पे दिस इज अ टी जॉइंट, तो आपके पास ये वैल्यू है और ये भी वैल्यू है, दिस इज अपवर्ड, दिस इज डाउनवर्ड, सो प्लस 34 माइनस 7.3, वैल्यू प्लस आएगी, उसको बैलेंस करने के लिए यहाँ पे वैल्यू माइनस रहेगी, यहाँ पे माइनस, यहाँ पे प्लस, तो अभी यहाँ पे प्लस जॉइंट है, यहाँ पे प्लस जॉइंट, तो बीम शियर, दिस कॉलम एक्सियल फोर्स, सो एडिशन ऑफ बीम शियर प्लस 2 कॉलम एक्सियल फोर्स विल गेट दिस वैल्यू ऑफ बीम शियर, तो इसका एडिशन करो, ओके। सो ये एडिशन प्लस आएगी बिकॉज दिस इज मोर देन दिस 2, तो इसकी प्लस आएगी, इसीलिए यहाँ पे डाउनवर्ड रहेगा। सिमिलरली you can find out for this and for this, so in this way you will get the values of beam shear. column axial forces से आपको मिलेंगे beam shear, अभी beam shear से निकालना है beam moment and column moment, okay, because you have to analyze this frame, because means you have to plot the bending moment diagram of beam and bending moment diagram of column. तो ये बीम शेयर का कैलकुलेशन हो गया, कॉलम एक्सियल फोर्सेस से आपको बीम शेयर निकाले, उसके बाद विल फाइंड आउट दी फ्रॉम द बीम शेयर विल फाइंड आउट दी बीम मोमेंट एंड कॉलम मोमेंट, ओके। तो बीम शेयर आपको मिला, बीम शेयर वी आर हैविंग दिस फॉर्मूला 2m/l, yesterday we have seen this beam shear 2m/l. अभी from this formula we can find out the beam moment, we can find out the beam moment, so m will be equal to VL/2. what is mean by V? V is the value of beam shear. तो पहले इसमें आप पहले इसका मैंने कैलकुलेशन आपको यहाँ पे करके बताया है, सो जैसे पहले इसमें यहाँ पे आप देख सकते हो दिस इज अ बीम शेयर, ओके, बीम शेयर आपको अपर स्टोरी फ्रेम में बीम मेंबर में ये बीम शेयर वैल्यू मिल रही है 7.3 अपवर्ड 7.3। तो बीम शेयर से तो V इज इक्वल टू ट्वाइस M बाय L, तो M विल बी इक्वल टू VL बाय 2। पुट द वैल्यू ऑफ दिस इन दिस इक्वेशन। तो यहाँ पे एक कॉर्नर बीम का मैंने कैलकुलेशन आपको बताया है 7.3 V बीम शेयर इंटू L यानी डिस्टेंस। ये डिस्टेंस आपको यहाँ पे दिखेगा। डिस्टेंस यू कैन सी दिस इज 4, दिस इज 4 मीटर डिस्टेंस। ओके, जैसे ये है यहाँ पे डाउनवर्ड 7.3। ओके, प्लीज कॉन्सेंट्रेट हियर। यहाँ पे अपवर्ड से दिस इज अ बीम शेयर, द डिस्टेंस इज दिस and this is the point of contact flexure located. So as this is downward, ये upward and this is ये upward है, तो यहाँ पे कपल क्रिएट होगा, तो ये डाउनवर्ड। विद द हेल्प ऑफ दिस यहाँ पे जो मोमेंट आएगा ये एंटी क्लॉकवाइज, तो यहाँ पे क्रिएट होगा क्लॉकवाइज मोमेंट। ओके, सो व्हाट इज द मैग्नीट्यूड ऑफ दिस मोमेंट which is nothing but VL by 2, 7.3 into 4 by 2 that is 14.6। और ये जो कपल क्रिएट कर रहा है मोमेंट that is a clockwise movement here. Okay, so यहाँ पे आप देख सकते हैं 14.6, 14.6। Similarly for second beam span आपको यहाँ पे देख लेना एक बार। ये 4 मीटर है, ये 5 मीटर है शायद से, और ये आपका 6 मीटर स्पैन है। ओके, सिर्फ आपको ये फॉर्मूला यूज करना है VL by 2, put the value, will get a moment of beam and every member of this beam there will be the clockwise moment. You can see here 14.6, 32.7. I have shown the calculation here 9.16 into 6 by 2। तो ये कैसे निकले अपने ये जो बीम शेयर है, you can see this beam shear। Okay, this into span divided by 2 you will get the beam moment। okay, तो इस तरह से पहले फर्स्ट अपर स्टोरी के बीम मोमेंट निकालो, सेम वे से लोअर स्टोरी के बीम मोमेंट निकालो VL by 2। यहाँ पे भी एक कैलकुलेशन करके बताया। ओके, इन ऑल द केस यू गेट द क्लॉकवाइज मोमेंट। ठीक है, ओके, सो फ्रॉम दिस बीम मोमेंट देन फाइंड आउट द कॉलम मोमेंट। अभी फिर से इक्विलिब्रियम मेंटेन करना है अपने को, ये समझ में आया। अभी ये क्लॉकवाइज, यहाँ पे जॉइंट है कॉर्नर जॉइंट, ये क्लॉकवाइज, ये एंटी क्लॉकवाइज, ये एंटी क्लॉकवाइज, यहाँ पे पॉइंट ऑफ कॉन्टैक्ट फ्लेक्चर लोकेटेड है, ये एंटी क्लॉकवाइज, ये भी एंटी क्लॉकवाइज। ठीक है, अभी ये क्लॉकवाइज मिल गया, ये क्लॉकवाइज मिला, यहाँ पे टी जॉइंट है क्लॉकवाइज क्लॉकवाइज, यानी यहाँ पे उसको रेजिस्ट करने के लिए मूवमेंट आएगा एंटी क्लॉकवाइज। एडिशन करो 14.6 प्लस 32.7 you'll get 47.3 but will be in the opposite direction. This is anti-clockwise, this is anti-clockwise. Likewise you calculate here clockwise clockwise plus, so it will be minus likewise। so यहाँ पे clockwise, यहाँ पे anti-clockwise, same यहाँ पे। so you can see in portal as well as in the cantilever method, so beam moment you'll get clockwise and the column moment you are getting as a anti-clockwise as per this assumption। end moment जो आपको मिल रहा है as per the assumption of this 1 and 2। then similarly this beam moment you have calculated, then from this beam moment you calculate the column। अभी यहाँ पे देखो आप, यहाँ पे this is a T slipping joint है, T joint, तो यहाँ पे moment है 14.6, this is the anti-clockwise moment 14.6, और यहाँ पे बीम पे क्लॉकवाइज है, तो आपको यहाँ का मोमेंट निकालना है। तो यहाँ पे आपको डोंट मेक अ मिस्टेक हियर, यहाँ पे 3 जॉइंट के मोमेंट को, 2 मोमेंट को ऐड करके आपका ये कॉलम मोमेंट निकलेगा। तो ये क्लॉकवाइज 53.48, सो प्लस 53.48 माइनस 14.6, इसकी एडिशन रहेगी प्लस 38.88, तो उसको रेजिस्ट करने के लिए एंटी क्लॉकवाइज रहेगी। ठीक है, जैसे यहाँ पे ये आपको पता है, अभी ये क्लॉकवाइज ये मिल जाएगा, तो ये क्लॉकवाइज एंटी क्लॉकवाइज क्लॉकवाइज। ठीक है, इसका एडिशन करके जो वैल्यू आएगी उसका अपोजिट यहाँ पे आएगा. Similarly here, and then last again ये clockwise 101.43 and this is anti-clockwise 27.57. इसका जो एडिशन रहेगा वो मोमेंट यहाँ पे रहेगा, क्योंकि यहाँ पे 3 मेंबर कनेक्टेड है. डोंट मेक एनी मिस्टेक हियर. तो यहाँ पे 101 करोगे और यहाँ पे एंटी क्लॉकवाइज नहीं, 3 मेंबर कनेक्टेड है. तो यहाँ पे जो कॉलम मूवमेंट निकलेगा दैट इज द एडिशन ऑफ दिस बीम मोमेंट प्लस दिस कॉलम शेयर. ओके, तो with the addition of this you'll get the moment here and ये moment आपका plus 73.86 रहेगा. तो यहाँ पे उसको रेजिस्ट करने के लिए एंटी क्लॉकवाइज, दिस इज एंटी क्लॉकवाइज, दिस विल बी एंटी. सो इन दिस वे we can find out the beam moment and the column moment. Once you get this, you'll be able to plot the bending moment diagram for beam and column. यहाँ पे I have not written the values here. We just note down the values of this bending moment while plotting BMD for beam and the column. So likewise, you can plot the BMD for beam and columns. So in this way, you can analyze the frame using this method. Okay. So only one problem can cover because of the time, and the same method, same process will be there, same steps you have to follow. Only the difference is that the load will get changed. Okay, area different रह सकता है and the load will change, and procedure is same. Whatever I have explained you, you have to go with the same process and you have to solve the problem. इस तरह से ही फ्रेम आपको दिया जाएगा, इस तरह से फ्रेम दिया जाएगा. Generally we are asking up to 2-story frame because it will require the time for the calculation. Only this load will get changed, and area if it is not given, you have to assume the same area for all members. Okay. So here I will stop now, and in this way our syllabus of SA2 is finished. Okay, I have completed the 100% syllabus. Okay. So I will send this notes on your class. Go through that notes and prepare for your exam. Okay. Please wait for 5 minutes.